We can also use these formulas to find the area of composite figures. So here's a figure that's composed of several rectangles. We know that the area of a rectangle is the base times height, or sometimes we could also write the same thing as length times width. It's the same thing. But using that, we can find the area of each of these sections of this composite shape. So first, we can look at the yellow. And we see again that the yellow is a rectangle. It has dimensions of 6 by 1. So we multiply the base times the height. So 6 times 1 gives us an area of 6 square feet. We can find the area of the green, given that it has a height of 3 and a base of 3. So 3 times 3 gives us an area of 9 square feet. And we can find the violet simply enough because we're given that the base is 2 and the height is 1.5. So that tells us that the area 2 times 1.5 gives us 3 square feet. Now the other ones, we're going to have to think a little bit to figure them out. So looking at this red, we see from this 3 feet, if this 3 feet is the height of the green one that's adjacent, that means that the height of this red section is also 3 feet, but we don't know, what we don't know is the length here. But we can figure it out because we know that the overall length from here to here is 6 feet. So if we were to draw that out, we could say that the overall length from here to here is 6 feet. We know that that's the case because it has to be, given that these are all rectangles. So rectangles necessarily have the quality of having equal sides. So if this is 6 feet here, this forms a rectangle. Down here, this total distance must be 6 feet. So if the total distance is 6 feet and this portion of it is 3 feet, that means that the missing distance here is also 3 feet. All right, so this distance from here to here, from here to here, is also 3 feet. All right, so given that this is 3 feet, this is 3 feet, we can conclude that the area of the red is also 9 square feet. And then finally, if we want to find the blue, we know that this portion, if this is 2 feet and this is a rectangle, then necessarily, because a rectangle is a parallelogram, that this opposite side is also 2 feet. All right, so we can go ahead and label this being the base width of the blue. Okay, so the base width of the blue there is 2 feet. But then we need to find this length of the blue side. So we can call that measurement out so we know what we're measuring there. So we're trying to measure from here to here to figure out what that is. And we can look at the entire shape now, the entire rectangle, and we see that if this side is 3 feet plus 1 feet, which is 4 feet, that means that this entire distance here also has to be 4 feet. So if this whole thing is 4 feet and a portion of it is 1.5 feet, that means that the remaining portion that we need to know has to be 2.5 feet. All right, so if we know that one side is 2.5 feet and the other dimension is 2 feet, we can conclude then that the area of the blue portion is 5 square feet. All right, so with that, we can find the area of the entire composite shape by adding up all of the component pieces. So we can say 6 square feet plus 5 square feet plus 9 square feet plus 9 square feet plus 3 square feet. And if we add all that together, we get that our total area is 32 square feet. And likewise, we can find the perimeter, the total perimeter of the shape by adding up the distance, going the distance around and adding up all of these dimensions here. So we start here, we can say 1 foot plus 3 feet, that's 4 feet, plus another 3 feet, that's 7 feet, plus another 3 feet, that is 10 feet, plus 2 feet is 12 feet, plus this 4 feet distance here is going to be 16 feet, plus 2 feet is 18 feet, plus a final 6 feet gives us our perimeter of 24 feet. So our perimeter, our overall perimeter is 24 feet.